are recording. Alrighty. Wanted to mention that because that was something that was kind of really cool that they were talking about in seminar yesterday. January 31st, Tuesday. Finished in lab. Sending around for attendance. And she wants to finish that off. Put a sign on it. Please don't shut that off. So while that's booting up, I ordered some stuff for our lab. Let's see what we got.
I picked it up.
Oh.
And brought it in here. I was freaking. I was like, what is this?
These guys are so cool. Have you seen these that they make? They're made out of baking soda. The packing peanuts. Environmentally friendly. A lot of times you'll get these guys and they're plastic. They're biodegradable. They're baking soda, puffed up, dried baking soda. So they will decompose and just go into solution. And that is absolutely wonderful from a landfill's perspective. So you don't end up with a lot of plastic stuff, plastic peanuts out there. Neat, huh? So that's cool. This is Forestry Suppliers that's doing that. And get our stuff out of here. Yeah, show you what we got. Oh, my little machine is booting up. Take a second. So we're going to be studying trees. Some of the things we're going to need to do that are some tools from the field. Thinking about that. There we go. Okay, so to do that, we've got a couple of instruments that we can use to make our job easier in the field. And that is hobo data loggers, because we want to measure temperature and light in the environment to kind of characterize the environment when we find our loblollies and the understory environment when we find our seedlings. So we want to be able to see these. These little data loggers are automatic. You set them to, you turn them on basically. They're called pendants. And they record, they've got little sensors, in there, battery operated. You literally put them out in the field and they will record ambient light and temperature in the area. All different kinds of these things, and some that are a little bit more elaborate than this, that allow you to do all different kinds of things like rain gauges and stuff like that. We have a weather station on campus that gives us local weather using onset and some other types of data sensors. out there. So we can measure wind, we can measure rain with a tipping gauge rain sensor out there, temperature, soil temperature, air temperature, humidity. There's humidity sensors. You can measure all kinds of environmental factors using these kinds of field sensors. And depending on how secure the area is that you're studying, it would be really wonderful if university could deploy a weather station in Marshall Forest, but it's public and it's difficult to minimize the risk of vandalism and theft on those kinds of things. That's why the weather station is actually on campus, so we have a little bit more oversight on it. So we've got our hobo sensors, and we've got these low-tech instruments that allow you to, and it's very explicit instructions and angular conversions and stuff like that, that allow you to pace a certain distance from a tree and use this instrument to, if you know the distance of the base of a triangle, and you know the, what would you call that, the stem of the triangle, the tree height, and then the angle to the top from this line from where this instrument is, and of course you have to take into account your height, right, added to the height to the top of the tree, and the angle tells you the height, that base. So this instrument, let me send it around, you can take a look there and take a look, see how it works. Here's the directions, let that come back. Oh, sorry. We come back around.
We used to do that with like the Biltmore sticks.
Yes.
This chain, like walk out the chain and then.
Yeah. You know your exact different. We're going to actually use yardsticks, or not yardsticks, but measuring sticks, so that we can have known distance from the base of the tree. We'll do that. The other thing you have to keep in mind is the angle, because you're not in Marshall Forest, you're not always level. Let me just kind of quickly see what we're talking about. So here's our tree. Here's the ground. Let's assume we're on a nice even plateau, and here you are with our little thing. We've got to the top of the tree, to where you're standing, and then the angle between that. Okay, now if the instrument is in your hand, the angle is to your hand, and the height difference you have to add to it in order to be able to find the height of the tree, right? So basically, it's a 90-degree angle assumed, and if this is the base, and I don't know, I can't remember what they call the long, and then this is there are names for this, and I can't remember the names of the parts of the
The arms of the triangle.
The arms of the triangle? Okay, I'll work with that. That works for me, arms of the triangle. Does that sound right? Okay, so this is the tree, basically. Now the problem is, you can have you down here and tree up there. There's a little bit of adjusting you have to do, because you're looking at the top, but you've got to correct for the slope that's out there as well. Hypotenuse is the angle, right? Is the hypotenuse is the angle. Is that the hypotenuse?
Yes.
Okay, I was going to say that, but I thought it was the angle, and I didn't want to misspeak. Yeah. So this is an easy instrument to do that. It's very low tech, as you can see, and as Madeline was sharing with us, you can do it's just as simple as knowing the distance you come out from a tree and taking a look up, and then you do some geometry to figure out the height of the tree. But there's even a better way that you can do this. I got one because I wanted you guys to see what you would find in the back pocket of a forester, somebody who works out there every day. They've got this little instrument, obviously more expensive than those. It's a precision instrument. It goes on your belt. And hangs around your neck. You look through it, and it calculates the angle for you and then there's a table conversion that you can use. And these guys know this so well that basically they can say this is the degree, this is the height. So you can look through where you're standing, and as you tilt up to look at the height of the tree, the angle changes. Higher, different angle, lower, different angle. Okay, so this is the instrument for that. Send that around. You guys can take a look at that. We'll get this guy working as well. There should be supporting documentation in there. So some stuff to play around with to help our time in the field be more instructive and a little bit expeditious, a little bit more expeditious. So, okay. So one of the things we'll have to talk about is where to deploy this in the field so that we can actually get some data out there. All right. Cool. All right. All right. Okay. Did the light turn green? I'll take that. Thank you very much.
It's blinking green.
Is it green? Okay. Don't worry about it. I'd like to use it once though before we drop it. All right. Awesome blossom. Now, one other thing that went out in the, well, two things that went out in an email. I want to make sure you've seen them. I updated my office hours. Everybody saw that? I now know when I'm meeting with other people, doing other things, so I can kind of adjust around those times a little bit better. It was a guesstimate before until I actually knew more and got settled into a better schedule. So, and Luke, just so you know, I think I'm opening chapter 2 here. I'll have to open chapter 3. Oh, here we go, chapter 3. Very good. Lecture notes. We, Luke, we were out in the wet lab as we designated that we were going to do at the start of class today, and spent some time finishing up on some of our measurements. The students will share with you some of the stuff that we got finished. We had to go back and work on the ash-free dry weight one. The oven didn't turn on, so I'm going to figure out what we need to do to set that up and get it to do its thing. So let me get the board a little cleaned up here. All right, that's really terrible. And I took my rag. Okay. Let's see it in your view. Sometimes it falls in there.
Is that it over there?
Where?
On that table.
Oh, there it is. Thank you. That's what we can use. Hold on to the moisture a little better. All right. Now. The other thing that went out in the email was a new date for the exam, giving us a chance to get caught up a little. And I moved it to next Tuesday. However, I'm told that there's an exam in physical geology, the same day, the class just before this. So instead of moving it just, I'm trying to actually think, I was trying to, look at this. Isn't that cool? That's neat. I was trying to avoid mashing up our next exam right close to the moving of this exam. So let me take a quick look at our schedule.